When it comes to working with LUTs, you need to know where to put them. This is something you just have to get right. Otherwise, you might ruin your grade without even knowing it. And if you're not ruining your grade, you are probably wasting your time. Before we jump in, I want to clarify that we will talk about a basic concept called signal chain hierarchy. Even though there are exceptions, this is not up for creative debate. There's a definitive right and wrong way to do this. Again, yes, there are exceptions, but we will talk about breaking the rules after learning the rules. Part of the reason why the LUT placement is so important is because LUTs are destructive adjustments. So, what on earth are destructive adjustments? Destructive adjustments are adjustments you can't reverse with the reverse operation. Okay, this sounds complicated, but it actually isn't. Let's apply two instances of color wheels. And to see what we're doing, let's bring up the scope, so I will go into my color grading workspace. Here we go. With the first instance of color wheels, I will crush the shadows. Even further still, and as you can see in the waveform, everything gets clipped here. To find out whether or not color wheels are destructive adjustments, let's try the reverse operation. So I go into the second instance of color wheels. Again, this is the current signal we're working with. There's nothing in here because everything has been clipped. However, color wheels is not a destructive adjustment. Therefore, I'm able to bring everything back just fine. If I would match one operation and the other perfectly, there would be no change visible. But I don't want to waste time on getting this perfect, so you have to take my word for it. Let's get rid of the color wheels. Now I apply a LUT. This shot was shot in S-Log3, S-3.Cine, so I will go into the Cam2Rec LUTs, Sony, S-Log3, S-Log3, S-3.Cine to Rec 709. By the way, Cam2Rec is a free LUT pack I made for color space transformation from all sorts of different cameras to Rec 709. You can download it from our website. Okay, so let's apply the LUT and have a look. The image got converted nicely. Let's apply an instance of color wheels and move it before the LUT. If I now do the same thing, I will just crush the shadows and place another instance of color wheels after the first instance of color wheels. We are able to bring that back just fine. No artifacts whatsoever. Let's reset this. If I now move this instance of color wheels after the LUT and try the same, let's have a look. You can see the footage behaves strangely because we cannot pull back the shadows. I will leave it as is and just move it before the LUT. Have a look how everything came back just fine. Again, after the LUT and before the LUT. This is because applying a LUT is a destructive adjustment. Everything that gets clipped by the LUT is gone for good. So again, if I disable the second instance of color wheels, you can see how we clipped almost all information down here. If I move this instance of color wheels after the LUT, there is nothing I can do about this. This information got clipped by the LUT. If I disable the LUT, you can see how everything comes back just fine. But the LUT clips this information. Therefore, LUTs are destructive adjustments. The reason why LUTs cut off information is a topic for another video. For now, it's only crucial to know that they are doing it. To reiterate, before the LUT, we have the larger recording color space, whereas after the LUT, we only have what's left after the conversion to Rec 709, which makes the LUT, or the color space transformation in general, a crucial breaking point. Therefore, colorists distinguish between the scene-referred part of the signal chain and the display-referred part of the signal chain. Stay with me, it makes sense in a second. To illustrate this better, let's have a look at this image. This is a page from my free guide on the basics of signal chain hierarchy, which you should definitely pick up. The link is in the video description. As just discussed, before the LUT we have all the information available our camera was able to capture. Hence, it's called scene-referred, because all adjustments we apply before the LUT reference the recording color space. The LUT's job is to transform the color space from the recording color space to the displayable color space, like Rec 709. Therefore, all adjustments after the LUT are called display-referred. Again, because all adjustments we make after the LUT only operate on the display color space. Now we can answer the question why we couldn't pull back our exposure after the LUT. Reason 1, the LUT is by definition a destructive adjustment. And reason number 2, since the LUT clipped the information, there is no information in the display color space left. In other words, in the display-referred part of the signal chain is no information we could pull back. In the display-referred part of the signal chain, this information doesn't exist anymore. So the answer to the question where you should place your color space transformation LUT is at the very end of your signal chain. This could be either at the very end, at the very bottom of your inspector, because as you know, the signal flows through the inspector from top to bottom, or if you have multiple adjustment layers, you should put it at the topmost adjustment layer, because in the inspector, the signal flows from top to bottom, and in the timeline, the signal flows from bottom to top. For the sake of this example, let's apply a LUT, and let's say you have other adjustments here as well. For example, color wheels, color curves, hue saturation curves. If you have other adjustments on your adjustment layer, you should then put your color space transformation LUT at the very end. Again, if you're using adjustment layers, on the topmost adjustment layer at the very end of the inspector. Now that we learned the rules, let's break the rules. To reference the free guide you should definitely pick up one more time, let's take a look at this diagram. Here you can see the different stages during the color grading process. You can see that the output device transformation is at the very end of your signal chain. The output device transformation is just a fancy term for the color space transformation to your display color space. The exception is that some look development tools require a Rec 709 input. Another exception would be if you 100% know what you're doing. Then and only then should you make adjustments after the LUT. Let's summarize what we've learned. Number 1, LUTs are destructive adjustments. Number 2, all corrections before the LUT reference the recording color space and are therefore called scene referred. All adjustments after the LUT can only operate on the display color space and are therefore called display referred. Number 3. Display referred grading is by definition an inferior way of grading since you only have the information of a smaller color space available. Number 4. The color space transformation LUT should therefore be placed at the very end of your signal chain. A proper understanding of the signal chain hierarchy and the order of operations is as close to magic as you can get when learning color grading. In the video description, there is a link to a free guide I wrote on that topic. And if you wonder how that all applies to adjusting exposure during color grading, you should watch this video next.